Hello, in this video we'll be looking at how to transpose a matrix A. So when we do a matrix transpose, the most simple way to describe it would be we switch the rows become the columns and the columns become the rows. So if we have a matrix here A, our matrix is a 2 by 3 matrix, and our numbers here are represented by A in the first row, first column position, A in the first row, second column position, and so on and so forth. So our transpose, if we're going to make our rows become the columns and the columns become the rows, so our new number, so our row number will become the column number, so we'll have a 2 in the column spot, and our columns will become the rows, so we'll have a 3 in the first one. So our A transpose matrix has to be a 3 by 2 matrix. So we'll just switch these two around. So then what we see here is we have our first row of A11, A12, and A13 is going to become our first column of our transpose matrix here of A11, A12, and A13. And then we also have, for our second row, we have A21, A22, A23 is going to be our second column of A21, A22, and A23. So let's kind of take a further example look here. So if we have matrix M, and we have 3, 4, 2, 0, 1, 6, 6, 3, 1. Well, what we have here is a 3 by 3 matrix. We have 3 rows, 3 columns. So that means our matrix transpose, represented with this T right here at the superscript, is also going to be a 3 by 3 matrix. And what we'll do here is we'll just take our row, so our first matrix row, and we'll put it in the first column. So we'll have 3, 4, and 2. And then for our second row here, we'll have second row of 0, 1, 6, and we'll put it in our second column. So 0, 1, and 6. And then finally, we have our last row, and we'll put it in our last column. 6, 3, and 1. So the best way that I keep track of this is we always know we're making our rows become the columns. So we'll use the rows of our initial matrix M, and we'll just put it in a column slot here. So kind of taking a look at another example here. This time we have matrix A is equal to 4, 1, 3, 6, 2, 0, 1, and 1. So the best way to figure out what our transpose matrix is going to be is to look at what our rows and columns of our first matrix is. So for this one we have 1, 2, 3, 4 rows, and we have 1 column, 2 columns. So remember, we just have to switch our rows here, rows and our columns. So for our A transpose, we're going to have a 2 by 4 matrix. Because we have 2 columns will now become our 2 rows, and we have our 4 rows will now become our 4 columns. So we'll set that up here. We'll have 1 row here, 2 row there, and we'll have 1, 2, 3, 4 columns. So again, we'll take a look at our rows. So first row is 4, 1. That's going to become our first column. So 4 and 1. And our second row here is going to become our second column. So we'll have 3 and 6. And our third row of 2 and 0 will become our third column. Can we 2 and 0? And finally, we have our last row of 1 and 1. We'll put that in our last column here in our new matrix. Will be 1 and 1. So our A transpose then becomes 4, 1, 3, 6, 2, 0, 1, and 1. So the trick to this one is just making sure, you know, you write, if you're getting a little confused on this part and what your end matrix transpose is going to look like, to make sure you write down how many rows and how many columns are in your initial matrix, to then figure out, well, how many rows and how many columns are in our final matrix A transpose.